So here we're going to be working today on similar triangles. Let's begin working on the introduction to similar triangles worksheet. The ideas here will introduce you to the basics. Even if you're not sure what you missed, this would be a good place to start. So we're going to start off by thinking about the similarity theorems that we have. Okay, there's 3 similarity theorems. All right, if you are working with a notebook right now, this might be a good place to go have these. Okay, 3 similarity theorems that we're focusing on right now. We're going to learn how to apply them in this video. The first one would be angle-angle similarity. Then we'd have side-angle-side similarity. And then side-side-side similarity. So these are the 3 theorems that are covered. We'll talk about examples and non-examples. Okay. One of the first things that I get you guys to do on these kind of problems is to read them and make sure you understand what the question's asking. So first of all, it's asking us to state. So it wants us to make a statement about whether or not these triangles are similar. Okay, so we got to understand the definition of similarity. So we'll be talking about that. And we also want to state how we know that they are similar. And this, the way that we know, goes all the way back to our similarity theorems. These would be the ways that we know. Okay, we have 3 different ways that we could know that they're similar. So we're going to learn how to apply these. All right, they're going to feel somewhat similar to what happened in congruent triangles. So here we go. We'll jump in right now to our first problem. All right, the first thing that we would do when we're looking at these kind of things is to apply any 1-second geometry techniques, any little simple marks that we can make on it. Okay, if it's a simple thing to do, we want to do that now. So the first thing we would add is this vertical angle pair. Okay, and as we practiced in the last one, we're going to mark only one triangle when we label our pairs of angles. Okay, so we have an A. We circled the A because this is a pair of angles. All right, so both of these angles at D are equal to each other. Well, now we want to look at these parallel lines. Okay, those arrows on FE and CD mean that these are parallel. So if you can recognize this transversal going across both parallel lines, we see that we have some alternate interior angles here that we should have marked. So we would want to say that this angle F is equal to the other angle at T. So now we can realize, wait a minute, I have another pair of angles, right? Angle T is equal to F. So because we see that we have 2 pairs of angles, we really have enough information right now. Okay, so we can say that these 2 triangles are similar. Okay, so we're going to say that D has to be equal to D because both of these angles are there. So we just have D equal to D. Okay, the next thing we could think about is which one would E be equal to. Okay, well we can see that angle E in DEF has no mark. So that would go with U. And then we can see that T has 2 marks and so does F. Those both have 2 marks. So I'm going to erase it so you can see the letter a little better. Okay, but that's F and T. So we have DUT. So it's pretty close to being done, but it's not complete. What we have to have right now is a theorem. So we'd want to say by, okay, and what theorem? And again, we had 3 different ones. Okay, we see A. So we will use the angle-angle theorem. Okay, we can see that we have 2 pairs of angles that are congruent. Okay, so this would be basically the way that we want these problems to go. So this is number 1. Okay, now we'll be going back and forth thinking about the definition and how to apply the definition of similarity to these problems. So let's look at this example and think about what's happening here, okay? We know that in any triangle, the 3 angles have to be equal to 180, right? The 3 angles have to have a sum of 180. They must add up to 180. So when we look at this, I know that this angle right here must be equal to that one. And we could even figure out what the number has to be, right? Because I know that 30 plus 32 plus that angle, whatever it is, we could put an X there if we wanted. Okay, I know 30 plus 32 plus X must make 180. So what would that angle have to be? Okay, well we can see this is 62 and that's 180. So if I was to subtract 62 from both sides, we can see that we'll get 118 for that angle. Okay, so that means I could go label my picture, right? I could go put 118 in that spot. And since we know those 2 vertical angles are equal, that tells me that this other one must also be 118. Okay, So now this brings us back to our definition of similarity. And the definition of similarity is pretty specific about all the corresponding angles have to be equal. So think about it. 118 is equal to that one. So we do have one pair of congruent angles. So that's fine, okay? But 26 is not equal to 32 or 30. So because this angle right here is not equal to either one of those, that means that there's no way that these two triangles can be similar. So in this case, we would have to say not similar, okay? Because similar triangles have to have three pairs of congruent angles, okay? So in this case, we can say that these triangles are not similar. And, the reason why they're not similar is because we have a pair of angles that will not be congruent, right? S will not be equal to either L or M or N, so we know it's not similar, okay? So I'm trying to make that obvious. What I think right now is we'll take a look at some definitions really quickly. So here we have a definition of congruence, okay? Two triangles specifically are congruent if they have the same size and side lengths, okay? So not only are the angles the same size, but the side lengths are also the same size. So we've been using this idea for a while to understand what similarity meant and what congruent meant. Okay, we have our angles are equal, and we have three pairs of congruent sides also. Okay, now when we take a look at what similarity means, okay, we have our idea here that it means that basically two triangles are similar if their corresponding angles are congruent, like we said. But this time the corresponding sides have to be proportional, which is a way of saying that they have an equal ratio if we take corresponding sides. So if I take AB and divide it by XY, because those sides correspond with each other, right? If I compare that to another pair of corresponding sides, I will get the same proportion, okay? So these, if I divide them, I basically get the same number. So all of these fractions are equal, and that's the idea, okay? And so now we have a different symbol, and we use this symbol called the tilde to indicate that triangle ABC is similar to triangle XYZ. Okay, so this is one way that I had you guys write down the definition, and we can see that the angles just have to be equal. It's not, there's no mystery there really, okay? So let's compare the two ideas, right? Congruence versus similarity. What's the difference, okay? Congruent means they have the same shape and the same size, whereas similar means that they have the same shape, but they might be different sizes, okay? So we have to be careful about that idea. We don't want to get these two confused. All right? The 1 second geometry would be something that we want to deal with here. So I'll put that in this video to make sure that everybody understands how we're going to apply these things. And we'll go through and do each example. All right? So the first one would be marking vertical angles. Okay, so anytime that you see two lines that cross themselves, okay, we need to mark the angles that are of use to us. Okay, so if I have this triangle is equal to this triangle over here, then maybe I need to show that these two angles have to be the same. It doesn't matter how many arcs I use as long as I show that they have the same amount, right? So if I'm trying to show these two angles are equal, they should maybe both have 2 arcs or both have 3 or both have 1. Okay, so we mark vertical angles very quickly anytime we see them. Okay, so I don't care which other way. We can also say that this angle is equal to that one. Okay, so anytime that you see that, we have to mark that really quickly. Okay, what this means is that if we're looking at a problem like this, and I tell you, hey, this is X, and this is 70, I don't know, maybe not make it 70, maybe something more like 17, all right? If that's 17 degrees, what would X be equal to? And you have to know, okay, just by walking up to that problem, X must be equal to 17 because we call those vertical angles, okay? So you have to be able to mark those very quickly. All right, the next thing that we'll take a look at is titled as marking common sides or angles. All right, so there's 2 situations here that we want to talk about. All right, we'll talk about marking common sides first and then common angles second. Okay, so for common sides, what we have there is basically a shape where we have 2 triangles that are stuck together. So when we have a side that's in both triangles, I wanted you guys to come mark it quickly and label that as one pair of sides by itself. Okay, so these things happen really quickly. And like I said, now we'll take a look at common angles, okay? So a common angle occurs when we have a triangle inside of a triangle. And if you can see here, we have two triangles. We have a smaller one inside the bigger one, okay? So in this case, I'll consider this smaller triangle the blue triangle, okay? And I want you guys to look for, is there an angle that is in the blue triangle and the red triangle? And in this case, the angle that we're talking about is this one right here. So we would say that that is another pair of angles, okay? So this thing right here is called a common side, whereas this one is called a common angle, okay? This angle is in both triangles, so it's a common angle. You want to mark those very quickly, all right? We'll be practicing those in the video, all right? Other examples of one-segment geometry would include something like marking congruent radii of congruent circles, okay? And these are things that we do when we're working with our constructions, right? So if I was to have a circular arc, right? If I have a center and I tell you I'm drawing a circle, okay? Then we should be able to tell, okay, well, all of these lines need to be equal, okay? So if I tell you that that's a circle, then I should be able to tell, hey, this mark has to be equal to that one, okay? A lot of times when we're using a compass, we might copy a circle over onto another line segment, okay? And so if I copy that circle and I'm just moving it over to another spot and I know I didn't change my compass, then I would probably end up giving a mark to show that these two things must be equal to each other, all right? So anything that we mark with the compass could be something that we do really quickly. All right, the next one that we'd have for one-segment geometry would be parallel line angle pairs. Make sure I didn't miss one. So parallel line angle pairs go back to what we had during our Unit 5 exam. Okay, and some of you might have been absent or something, so this might be not review for you. You guys might be getting this for the first time, okay? So if we have two lines that are parallel, okay, we're indicating that the lines are parallel either by using words, right, or symbols. So the symbol for parallel that we use is these little marks right here, okay? And if I have this line right here that we call the transversal, okay, we learned to mark certain angles that were equal, okay? I try to really teach you guys that this, I think this picture really shows everything that you need, okay? We know that the linear pairs have to add up to 180, okay? But we also need to realize that because they're parallel, these corresponding angles must be equal. So since this is 80, this one up here will be 80, and since this is 100, this one right here must be 100. Okay, and if you think about it, now we have our vertical angles. So that has to be 80, and this must be 100. And likewise, this must be 100, and that must be 80. So we just use corresponding angles. And let's take a look right now. I'll use the red to mark the alternate interior ones, okay? For instance, this 80 is equal to that 80. And then this 100 is equal to that 100, okay? So we have these ideas that we want to be able to mark very quickly, and we'll need those every now and then on a problem. And it might seem impossible until you make that little mark and you realize that the only thing you didn't understand was, just something you overlooked. So be patient, because every now and then you might feel completely stuck. There's just one mark you have to make. All right. There's also the isosceles base angles, which became one-segment geometry when we learned it. Okay, I taught students that in an isosceles triangle, the two sides that are equal create this angle up here that we call our apex angle. Okay, so this angle up there is at the apex of our triangle, and we can call these other two angles down here, those are the base angles. Okay, and the base angles in an isosceles triangle have to be equal. All right, so these two angles must be equal to each other. So the way that we do this in a problem would be, you might see a triangle that looks like this, where you see 11 and 11, okay, and I'm expecting you students to know, okay, wait, these two sides are equal, so they make that angle up there, all right, those two sides are equal, so we mark them, and I know that the base angles must be equal, okay, the other two have to be equal, you got me? So once you find the apex, you know the other two angles have to be equal, so it's kind of important, all right, every now and then, I'll have students working on a problem like this, and you could see that these two angles look like they're the same. not these two. Okay, but every now and then I'll have a student that marks those two and tells me that they're equal, when that's not what is the truth here. We don't want to have that. Okay, what I told you guys is if you mark the picture, so if we had actual numbers on it that said 12 and 12 or something like that, well, now we actually have to think a little bit about what's going to happen here, right? We can highlight those two sides that are equal, the 12 and the 12. And if I darken them, now there's no guesswork, right? That's the apex, and I know the other two angles have to be equal. Okay, so these isosceles base angles are a quick thing that'll happen really quickly, and some problems will sneak up on you if you don't notice that there's an isosceles triangle that you can use. So now we have reached the end of the list, okay, with any information that is given by the hypothesis. So if the paper tells you that you're given that AB is parallel to CD, okay, if it tells you that and there's a picture and two lines are there, then your job would be to go add the marks that show that they're parallel, okay, depending what it is in the picture that it says, okay. It might tell you something else, like, you know, maybe two random lines are just there, okay, and we don't have any other information about them, and maybe the diagram says given AB equals CD, okay. Well, if they're equal or if they're congruent either way, what can I do? What can this statement tell me to do? Well, this is really 1-second geometry. It says AB equals CD. So I can put a little mark right there, okay, and just move on to the next part. So these simple marks actually play a big part in solving these problems that we're working on up here. So that might help you in either congruence or similarity, depending on where you're stuck. Let's go move back to the worksheet. So you can see now we looked at the definition of similarity, and we have some examples of marks that we should make on the page to get through problems quickly. So in this example number 3, we should be able to see at this point which theorem we cannot use, okay? Our first theorem, angle, is maybe the first one we want to try every time because it's simple and it would be a waste of time to do anything else because it's easier to tell if two angles are equal, okay? So when we look at this problem, we might jump and say, hey, look, these corresponding angles are equal, but we actually can't do that because we don't know that these lines are parallel. We don't know whether or not. In fact, if these two triangles are not similar, then we know those lines can't be parallel. So we cannot rely on that. We have to try. Okay? There is one common angle, and that's at K. Okay, so what that tells me is we have one pair of angles. Alright? But we don't have two pairs of angles. We only have one. So I don't know anything about E and D, so I can't make that distinction. So we can't use angle. Okay? But because we have one angle, I can try to use side angle side. So what that means is we'll be using the sides that are concerned with this angle over here. Okay, we'll have to add some numbers to the picture to make life a little easier. Okay, so we'll add some. Here we go. For instance, I know this side of the red side must be equal to 16. Okay, this side of the red triangle must be 16 because 16 plus 72, if I add those up, right, I get 88. Okay, so the two pieces must add up to the total. All right, well, if this is 99 and the whole thing makes 121, then this piece of the line must be 22. Okay, these are not drawn to scale. So I need you guys to understand that that's important. Okay, they are not drawn to scale. Okay, which means that you might have a line segment that looks shorter than it actually would be if these were drawn correctly. Okay, so not drawn to scale. Use the numbers to represent things, but don't freak out when you see that 99 looks shorter than 22. Okay, obviously it's impossible, but just deal with the picture as it is. So what we're going to do is find out if we have two fractions that are equal to each other. So we want to understand that side angle side is the one that we're going to use if we do know one angle, okay, and if it's the included angle of two sides that we know about, then we can use side angle side. So side angle side will have two fractions, okay, whereas side has three fractions, okay, and in these ones we want to check if all of these fractions are equal. So we need to use the corresponding sides. So what I'm going to use right now is we're going to say 16, okay, would correspond with 88. Let's try that. Let's see if 16 over 88, okay, what happens when we match that up with the other one, okay, with 22 over 121. Okay, so we're doing the inside numbers over the outside numbers. So what we want to do is break these down and see if they're equal to each other, okay? So we break down the fractions. It's probably the most important skill here, okay? 7 times 3 and 11 times 11. That gives us a problem because these numbers are all prime. There's nothing that we can cancel off the top or bottom. But we're going to put this one over here into last terms, right? 16 is 2 times 2 times 2 times 2. And 88 is 2 times 2 times 2 times 11. All right, 8 times 11. So we can't cancel some things on the left, so we'll go ahead and do that. All right, we can cancel a 2, and a 2, but we get 2 over 11 left over, okay? And on the right-hand side, since this is in lowest terms already right here, we can't change that. So we might as well just leave it as 21 over 121. Okay? These two fractions are not equal. All right, they're not equal to each other. They're both in lowest terms, and they don't look identical. So that tells us they're not the same. So therefore, we know that these two triangles are not similar here. Okay? So we'll go ahead and do our work like that. Okay? So continue. Again, we're trying to find an equal proportion. All right? If we would have found out at the end that we had 2 over 11 and 2 over 11, then we would say that these are similar. Okay, so let's keep working. The next one for number 4. On number 4, what we have here is another example of side angle side. Okay, we should be able to see a common angle and just walk up and mark that quickly. Okay, now I'm going to try to use side angle side. We know we can't use angle angle because again there's only one pair of angles, not two. But I know I'm allowed to use side angle side because we have at least one angle and I know something about these sides that we can use, right? So we'll be using this little triangle and then the bigger triangle also. Okay, so what corresponds with 5 in the bigger triangle, right? We'll put 5 over 31. Okay, if I put 5 over 31, then we want to see if that's equal to the other ratio, which in this case would be 6 over 36. So now we should be able to see on the left-hand side, there's nothing that we're going to be able to break down, right? It can't be done, okay? But 6 over 36 can be broken down into, right, this is 6 times 1 over 6 times 6, okay? 5 and 31 are relatively prime. Okay, those numbers have nothing to do with each other really, so we're stuck there, okay? Right, all the multiples of 5s either end with 0 or 5, so we know that fraction is done, okay? Well, we want to know if those are equal, and now we have them both in lowest form. So 5 over 31 is not equal to 1 over 6, and we know they're not equal because they're both in lowest forms now. So we have to put it into the lowest term we can, and if they don't look the same, then they're not equal, okay? So we have triangle UTS, okay? U is equal to U, because they're both right there, all right? We would do this, okay? But in this case, notice, we don't have to do any of that because they're not similar. So don't jump into that. I have some students come talk to me about that. We don't need it, okay? What you just want to write here is no, the triangles are not similar, okay? And we're trying to talk about non-examples too. So we had 2 examples of non-examples on this thing. Let's go take a look at something else. See what we get. All right. So on number 5, we finally get an example of side, side, side. This problem, I feel like these are really the easiest because there's only really one way to go, and someone get sidetracked every now and then. So let's make sure that we understand how to use side, side, side. Okay, in this case, we don't know anything about any of the sides. So I would appreciate it if you guys would be able to say, wait a minute, I don't know anything about any of these angles. There's no marks anywhere. There's no 1-second geometry. We have no vertical angles, nothing common. So that means I can't use 1 and I can't use 2. Okay, because these triangles are not connected at all, there's no way that I can exploit anything about the angles. So we want to be able to recognize that right now. Okay, so that means we're stuck with side, side, side. All right, and this means we're going to use three fractions, and we're going to compare to see if all of them are equal to each other. If one of them is not equal to the other two, then we know they're not similar. Okay, so what I usually teach students to do is find the biggest side from the first triangle. In this first triangle, the biggest side is 65. Okay, we're going to compare that to the biggest side in the other triangle over here. So in this, we'll call this the red triangle, and let's call this other one the blue triangle. All right, what's the biggest side in the blue triangle? Well, in the blue triangle, the biggest side is 13. So what we have here is we can write 65 over 13. Okay, so if I write 65 over 13, we want to make sure everything else matches up the right way. So what I'd like to make sure that you guys understand is that since we started in the red triangle and started putting things on the top from the red triangle, everything on top should all be from the red triangle. Okay? If it's on top, then it's from the red triangle. And if it's on bottom, then it should be from the blue triangle. All right, there's more than one way to do this. All right, I'm going to say that I'm going to teach you guys one way to do it, and if you guys find the other way, I'll let you know you found the other way, and that's cool. But I'm going to show you guys just one way so that I don't confuse people. Okay? So the smallest number in this triangle is 35. So now go match that up with the smallest number in the blue triangle. The smallest in the blue is 7. So we'll put 35 over 7. Okay, so 35 over 7. Then we have to get the last one. Okay, should I write 50 over 10 or should I write 10 over 50? Take a beat to think about that yourself. Okay, I want to write 50 over 10 because we have everything starting with the triangle on the left, with this red triangle. So like I said, everything on top should be from the red triangle, okay, and everything on bottom should be from the blue triangle. Okay, so if I was going to fix this pattern that I had, I would write 65 in red so that you guys could see it. Okay, so now we set it up fine. That's good, but it's still not done. Okay? At this point, we have to see if they're all equal to each other. Okay, so we want to know what's happening. Okay, 65 happens to be a multiple of 13, doesn't it? We have 1 times 13 here, okay? But what is 5 times 13? All right, 50 plus 15 makes 65, right? So that's correct, all right? 65 is 5 times 13. On top, we have 7 times 5 over 7 times 1, okay? So we're getting somewhere. And now we want to break this down because this is 5 times 10 over 1 times 10. So, what can I cancel? In this first fraction, I can cancel the 13s, I can cancel the 7s, and the 10s. And so we see that everything creates a 5 over 1. And so we should be able to see that they're all equal. Okay? And since they're equal, that means we have our theorem. We have correctly used, not side angle side. How many fractions do we have? We have 3. So we have side, side, side. All right? 3 sides means 3 fractions. Now I just want to make sure we label this correctly. Okay? So, NM. Okay, we want to make sure that we know which angle goes with N. Okay? So I see in this triangle that N is across from 35. Okay? And I see that 35 is the littlest side. It's the smallest side. You see that? All right? It's the least. Okay, the smallest number. Well, which angle is across from the smallest number in the blue triangle? All right, in the blue triangle, N is across from the smallest side. So that means that N goes with N. Okay? Let's look at M. Okay? M is across from the biggest side in its triangle. Okay? So across in this triangle is Q. Q is across from the biggest side in that triangle. So that means M goes with Q, and the last letter is R, and so we really don't have to think about it. Okay? So all you have to do is choose the first 2 correctly, and then you really can't go wrong because there's only 3 sides to choose from. So, we have an example of side, side, side that we've just seen here, okay? We don't say, yes, they're similar unless each fraction is equal to the same thing, and notice all 3 are equal. Okay, so at this point, we would have a good example for you guys to work on your own and see if you guys could figure out what the answer would be. Okay, so try this one on your own. Pause the video if you didn't do it yet. Okay, and if you did do it, let's see an answer. Okay, you guys should have that these are not similar. Okay, it looks like it might be side angle side, but if we set up these fractions and break them down, we should be able to tell that they're not similar. Okay, let's go ahead and take a look and see what we would get. So in this case, I tell students, look for, of course, we have an angle. So we know we have one pair. Okay, so we know we cannot go for angle, angle. We don't have enough angles, all right? But because we have one angle and a couple sides, and also because we know about the two sides that make that angle, okay? Again, 16 and 9 happen to also make that angle, okay? If this 16 was written right here, or if the 9 was written over there, we would have to say not similar, and we wouldn't even be able to try this, okay? But because we have the included angle of these two sides, okay, we can try. So the biggest side is 35, and the biggest side in this triangle is 16. So we'll put that one together. Let's do 35 over 16. Okay, if I have that, my other one should be 21 over 9. Okay, so notice that we have the bigger numbers on top and the smaller numbers on bottom. Okay, since the first one is bigger over smaller, the other one should be the same way. So try to make sure that you pay attention to that. All right, be precise when you're setting up your problem. That first step is important. All right, then we have 7 times 3 over 3 times 3. And then on this side, we don't have any way of breaking anything down, right? If we look at it, we have 7 times 5 over, as we said before, 16 is just a bunch of 2's, right? 2 times 2 times 2 times 2. There's nothing I can cancel out, all right? On the right side, I can cancel out the 3's, but not on the left side, okay? So on the right, we have 7 over 3. But on the left, I cannot change this. And since I can't change anything, that means it was already in lowest terms. So these are not equal, all right? Since both fractions are in lowest terms and they do not look exactly the same, they're not equal. Okay, so we just say not similar, and we don't have to actually complete that part of the statement. Okay? Let's take a look at the next examples. So this would be a great example for you guys to take a look at. Okay, think about it right now. These parallel lines and the 1-second geometry give you a clue. All right, but you should have angle, angle for this one. All right, so in the case that you didn't pause the video, I'm hoping you mark these two angles at S. We should be able to say that T is equal to B. Those are alternate interior, and A and U are also alternate interior angles. So then at the end we should have SBA, should be our triangle that goes in this place, and then it should say by angle, angle, similarity. All right, now number 8. In this case we have two choices. You could use side, 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 or side angle side. It's up to you, okay? I'd probably rather break down 2 fractions than 3, so I usually tell people to use side angle side instead, right? So in this case, you should get triangle FCD is similar to FGH, all right? So set up your fractions correctly on that one. Let's try the next one. All right. So in this case, we're extending our definition to polygons. We won't talk about it too much, but we have to at least introduce the idea. So similar polygons are just like similar triangles. They have to have that same definition. We have to have all of our angles the same, and we can see because these are parallelograms, these lines continue moving. All right, we have them extended. So as we do that, we can see that on this side we have to have 105 and 105, and because of our same side interior, I know that these have to add up to 180, right? These two same side ones have to add up to 180, so 105 and 75. So in this case, these two polygons, right, these two parallelograms have all corresponding angles equal. So we have the first thing done, right? Corresponding angles, all right? Corresponding angles are congruent. That's fine. All right, check. So are congruent, okay? But for number 2, we have to check that ratio of corresponding sides. So let's see, what happens when I do 18 over 6, right? 18 is the smaller of these two, and 6 is the smaller, so let's put those two corresponding sides together. All right, if we do 18 over 6, is that equal to 24 over 8? Okay, and if we break these down, they will both break down to 3 over 1. And so we see that these are similar. So we would say yes. All right, the parallelograms are similar. All right, so we're moving through this worksheet. I'll try to have you guys set it up so that you guys have just enough to practice. So for number 10, we should be able to take a look at this one and see really quickly these ones are not possibly going to be similar, okay? Because 60 is not equal to 50. And this is basically that simple to see, okay? Similar triangles have to have all corresponding angles the same. So it will be a quick little exercise to find out that in these two shapes, none of them are equal. All right? In a parallelogram, like we said, the opposite angles have to be equal. So this is going to be 130, and that's 130, all right? Because again, also, the same side interior have to add up to 180. So this would be 120, and that would be 120, okay? So in this case, we would say not similar, okay? And they're not similar because we do not have 4 pairs of congruent corresponding angles. So we don't even have to worry about the sides at all in this case. Okay, in this case it tells us that they're similar and then asks us to find the missing side length. So to do these problems, in this case it's kind of self-explanatory how to set it up. The shapes look, pretty similar, right? We put an X for the question mark and realize that's what we want to get, okay? So X is going to correspond with 10. So if I did X over 10, okay, I would set that equal to, am I going to write 24 over 16 or 16 over 24? Well, notice that I started in this shape over here. So everything should be from that shape. All right? I think that's the easiest way to get these problems done. So now, the way that I taught students to do these problems would be cross multiply. Okay, we're going to get 16 times X. And that makes 16X. Okay, on the right side, we have to do 24 times 10. So 24 times 10 is 240. Now, we just have to divide both sides by 16. So when you divide these things by 16, you guys might need to reach for a calculator every now and then in the next unit, but I really believe that you guys could do these ones in your head. So go ahead and actually try for a little bit to break it down. Maybe you could cut it in half and then keep going and write. If you think about it in class, the way that I did this problem was to recall that 16 is equal to 2 times 2 times 2 times 2. So if I divide by 16, that means I have to cut something in half 4 times. So half of 240 is 120, right? I cut it in half 1 time. Half of 120 is 60. We cut it in half 2 times. Half of 60 is 30. We cut it in half 3 times. So the last time that we cut it in half, the 4th time, I get 15. Okay, so like I said, you don't always have to reach for a calculator, but you should be able to get 15. Okay, so that's number 11. So cross multiplication is the way forward in the rest of these problems also. So in this case, we do the same thing. Okay, we can see that X in this case would have to be 3. Okay, and we can see 7 times 2 would make 14. And 3 times 2 would make 6. So that's kind of the way similar triangles work. Okay, well in a problem like this, let's do this one and then the video will be done at this point because this is pretty much everything that we need. Okay, to work on this example, we don't need to use theorems anymore. And the reasons that we don't need theorems is because it tells us that they're similar. So this information is basically given to us by the problem, right? We know by hypothesis that if I put corresponding sides, then they have to be equal, okay? So if I use 36 over X, okay, then that has me doing the inside number over the outside. So I'll do the same thing here. We'll do inside over outside. Okay, so we can do 44 over 143. Okay, now if we just do this in our calculator the whole way and just knock out the problem, we can do 44 times X makes 44X. Okay, And then on the right side, we have to do 36 times 143. Okay, so just be patient and do the calculation that you have to do. In this case, we get 5,148. Now, how do we solve for x? Okay, I want to get the x by itself, so I have to divide both sides by 44. If I divide both sides by 44, then I can cancel that out, and in the very next step, we'll have the answer. So we just have to divide that by 44, and we get 117. Okay? So, these are the way that we would solve these problems: cross multiply and then divide, and we'll work through it. Okay? So I didn't want this video to run too much over, so maybe I'll give you guys a couple more answers and just talk about one more problem. Okay, we'll take a look at 16 to make sure that students can have an example here. So on these kind of problems, a lot of times students want to guess, and that's not the way to do these. We don't want to guess. You want to look at the letters that we have. So I know that I want to get x. I want to find that. So I'm going to go darken this side right now. This is S-U, okay? And I see S and U are the first and last letter. The first and last letter and the other one are S and H. So that tells me that X and SH are corresponding sides, okay? So we're going to go ahead and put X over 22. Okay, if I write that, what would my other one be? Am I going to write 30 over 20, or do I write 20 over 30? Okay? Well, think about it. Like I told you guys earlier, if I start in this triangle right here, right, X is on top, so that means everything from this triangle should be on top, okay? So if we call this, for instance, the blue triangle, right, then that means everything on top should be from the blue triangle. And if we call that other one the red triangle, yeah, then everything on the bottom would be from the red triangle. All right, so that means that 20 would be right here, okay? And then simply cross multiplying, like always, will get us to the end. We'll have 20 times x is 20x, and 30 times 22. After we do this step, we're just going to divide by 20, and we'll be done. So 30 times 22 gives us 660. And then if I divide both sides by 20, then we get x equals 33. Okay, so that would be the way to show your work. There might be some other ways to think about this problem and figure out what's going on there. But this is one solid way that'll work for every single problem. Okay, you might be able to be clever in certain situations, and that's always fine with me. But you should know how to do this actual procedure of cross multiplying. And then, of course, the last step I forgot to write, which was dividing by 20. Alright, so good luck to you guys. I hope you guys can learn something about how to do these problems. Look out for some videos coming up on the other topics of volume and surface area and constructions. Alright, good luck.